Hey guys, welcome back to Michelle's STEM Journey. I'm Michelle and I'm here today with another AMC Problem of the Week video. This week's video comes from the year 2007, 10A, Problem 16, and it deals with casework. I hope you all enjoyed this video and let's get started. The problem states integers a, b, c, and d, not necessarily distinct, are chosen independently and at random from 0 to 2007 inclusive. What is the probability that AD minus BC is even? Okay, so in this problem, it's asking us the probability that when you subtract two numbers, the difference is even. And so for the difference of two numbers to be even, there's only two possibilities. So case 1 is when both are odd. And that, what I mean by that is that the two numbers that you're subtracting, they're both odd. And so if we didn't know that, it's really simple. I actually just wrote it all out myself a few seconds ago. So you can just plug in some really basic numbers. For example, 7 minus 3, that's 4. And 4 is even, but then 7 and 3 are odd. So you can just try one and you'll figure it out. So it's really easy. But that case 1 is when both numbers that you subtract are odd. And in this case, though, the two numbers that we're subtracting, it's not just a simple integer. It's actually the product of two integers. So the product of two integers, a and d, or b and c, the product, it's acting as the minuend and the subtracand. So basically the two numbers that you're subtracting. And so what's tricky about this is that we need to figure out what is the probability that a and d would be odd, or b and c would be odd. So basically, for the product of two numbers to be odd, both of the numbers have to be odd. So I'm going to write this out really quickly. Okay, so here we have it. And so we are looking at the first case right here. It is when both are odd. When you multiply two odd numbers, it gives us an odd product. And so we just need to figure out what is the probability that a and d is odd. And so to figure that out, a needs to be odd, b needs to be odd. And so the probability of a number being odd in this case is 1/2. And that is because, so for example, from 0 to 2000, right? Because right now it is from 0 to 2007, but we're just going to stop at 2000 for the first part. 0 to 2000. There are 1,000 even numbers and the 1,000 odd numbers. And we can actually figure that out because if you think about it this way, we're going to make the range even smaller from 0 to 10. 0, 2, 4, 6, 8. 5 numbers are even. 1, 3, 5, 7, 9. There are 5 odd numbers in 0 to 10. And so if we see here, basically the pattern is that from 0 to 10 or from 0 to 100 or 1,000, 2,000, there is going to be 1/2 of the numbers are going to be odd, and then 1/2 of the numbers are going to be even. So we already know to 2000 it's a half would be odd, but it's to 2007, and they picked this number, and it's really amazing because we can go from 2000 to 2007, 2000, 2002, 2004, 2006. 4 numbers are even. 2001, 2003, 2005, 2007. 4 numbers are odd. Perfectly, it stops at 2007, and 4 numbers are even, 4 numbers are odd, in the range of 2000 to 2007. And so basically what we see here is that even if it goes from 0 to 2007, we are going to have 1/2 of the numbers that are odd, and then 1/2 of the numbers are going to be even. And so A would have 1/2 chance of being odd. B would have 1/2 chance of being odd. And so if we multiply the probability together, we get 1/4. And so this would be the chance that the product of A and D is odd. Okay, and then B and C is just the exact same thing. And so it's also BC. Okay, so the probability that AD minus BC is even in this case would be 1/4 times 1/4. Okay, so that is when both AD and BC are odd, and so this gives us 1/16. So that is the probability for when both are odd. Okay, and then case 2, it is when both are even. And I'm going to take a really, really nice shortcut here because we already figured out that the probability that AD and BC they're going to be odd is 1/4, right? And so as a result, if AD has a 1/4 chance of being odd, then it'll have a 3/4 chance of being even. Okay, and that applies to both AD and BC. And this is simply, I think it's really just like common sense, I guess, because I mean 100% is everything, and if we have 1/4 that is odd, then the remaining would be even because there's only two possibilities, odd or even. And so AD would have a 3/4 chance of being even, and then BC would also have a 3/4 chance of being even. So the probability that AD minus BC is even under the scenario that both are even would be 3/4 times 3/4, which gives us 9/16. Okay, so we have both of the scenarios down because looking right here, there's only two cases when odd minus odd gives us even, and then even minus even gives us even. So we have both of the cases, and then we have both of the probabilities. So now all we have to do is add them up. So 1/16 plus 9/16 gives us 10/16. Simplifying that, we get 5/8. And so the answer would be E, 5/8.